Welcome to the Deep Dive. This is the place we take a massive stack of sources, really distill them down, and give you everything you need to know about a topic, fast and thoroughly. Today, we're taking a journey into history, into biology, and into a pretty persistent mystery as we unpack the life and legend of the thylacine.
That's right.
You might hear that name and think, Tasmanian tiger, maybe marsupial wolf, whatever you call it. We're talking about a fierce predator that once roamed Australia only to vanish into the deep Tasmanian bush. But the thing that sets the thylacine apart from almost every other extinct creature is that the story didn't really end when the last animal died.
That's absolutely right. The thylacine is so controversial because, well, almost a century after its confirmed extinction, the public fascination and this hope for its survival, it's still so intense.
So that's our mission for this deep dive.
Exactly. We're going to cut through some of the folklore and give you the complete, compelling story. We're diving deep into its unique biology, the precise chain of events, both natural and man-made, that sealed its fate, and maybe that very small yet persistent chance that it's still out there.
Or that we can bring it back.
Or that we could bring it back. We're using historical accounts, zoological comparisons, and some really cutting-edge genetic research.
Okay, so let's jump right in with the animal itself. When you picture the thylacine, you're picturing a dog, right?
Not much. A bit smaller than an average pit bull.
And it got that famous Tasmanian tiger name because of those stripes, about 15 to 20 dark stripes running across its lower back and tail.
And those stripes are a huge biological clue. They weren't just for decoration, they were camouflage. They helped break up its outline in the tall grasses and shadows of the bush.
Ah, okay.
It functioned in the exact same way stripes do on, say, a real Asian tiger, or even smaller Australian marsupials like the numbat, which is actually one of its closest living relatives.
What I find so fascinating, though, is how similar it looks to the dogs and wolves we know. The shape is so pronounced that if you took away the stripes, you would just assume it was a canidae.
It's one of the most remarkable examples of convergent evolution, in the entire animal kingdom.
What does that mean exactly?
Well, the thylacine was a marsupial, so it's completely unrelated to a placental mammal like a dog. But because they occupied the same ecological niche, walking in packs, pursuing prey, being apex hunters, they evolved the exact same body plan. It's like evolution solving the same problem twice, thousands of miles apart.
So wait, if I'm a zoology student, right, and someone puts a thylacine skull and a wolf skull in front of me for an exam.
Right, a classic final exam question.
Is there a quick visual way to tell them apart? Or is it purely forensic?
There is, and that's precisely why it's so famous in zoology exams. They are notoriously difficult to distinguish.
Okay, so what's tell?
If you're ever in that high-stakes scenario, here's the little piece of knowledge you need. Look very closely at the palate bone, in the roof of the mouth. The thylacine skull has a pair of very distinct holes in that bone that are completely absent in true canids.
Wow.
That's the definitive biological giveaway.
That is an amazing detail and a true deep dive AHA moment. Now let's get into its identity as a marsupial, because that's where the differences become, well, profound.
Indeed. Like Tasmanian devils, its reproductive cycle was classic marsupial. The joeys were incredibly small at birth. They'd stay in the pouch for about 12 weeks.
12 weeks, okay.
And then they'd remain dependent on the mother until they were nearly half their adult size. Litters were usually pretty small, maybe 2 to 4 joeys, simply because the mother only had 4 teats.
And the sources pointed out this truly bizarre physical adaptation. A lot of people know about the female pouch, but the male thylacine also had one. That's unique among Australian marsupials, isn't it?
It is, yeah. And it was all about protection. The males used this pouch to shield their scrotums while they were, running quickly through the rough, dense Tasmanian bush. The description we found, which I think is perfect for understanding it, is that the male pouch functioned like a wallet in a purse, just a small protective fold of skin to prevent damage.
I love that image. A creature of biological paradox. A striped dog-shaped marsupial with a protective male wallet. Okay, so now we know what it looked like. Let's talk about its life as a predator. We know from historical accounts, even Aboriginal rock paintings from centuries ago, that they were once widespread, both on the Australian mainland and Tasmania. They were secretive, nocturnal.
And highly efficient. And if we look at their diet, we start to see the first major biological vulnerability. They definitely enjoyed birds.
Right.
The sources detail a preference for poultry and smaller game, so things like the now extinct Tasmanian emu, the Tasmanian native hen, and also smaller mammals like bandicoots and possums.
But the mechanics of its jaw seem so counterintuitive. I mean, it could open its mouth to an astonishing 80 degrees, almost like a massive yawn. That sounds incredibly powerful.
It does, but that's the trick. While the jaw could open incredibly wide, the thylacine just lacked the muscular and skeletal structure to apply significant force when it dipped down.
Oh, really?
Yeah, think of it like a hinge that opens really wide but is weak when you try to close it. This lack of bite strength meant it couldn't reliably take down large, struggling prey. Its diet was limited to smaller, softer targets.
So that huge jaw gape was mostly for show, not force. And that preference for small prey, particularly birds, is why hollow bird bones were supposedly the perfect meal for them. Minimal effort, minimal bite strength.
Exactly. And that preference for smaller, easier meals, especially poultry, becomes a catastrophic vulnerability when the thylacine starts facing external pressures. And it faced two huge waves of extinction separated by thousands of years.
Let's start with the first one.
The first wave was on the Australian mainland about 4,000 years ago. And the ultimate winner in that contest was the dingo.
This rivalry is a classic tale, isn't it? Specialization versus generalization. The sources are pretty clear. The thylacine, even as an apex predator, was a specialist. It focused on medium-sized, often smaller prey, and it couldn't handle long periods of scarcity very well.
Whereas the dingo, by contrast, was a much more resilient generalist hunter. Dingoes could survive on a far more varied diet, they could scavenge when necessary, and they adapted to changing food sources really quickly.
So when things got tough?
When things got tough during droughts or when prey was scarce, the dingoes survived. They reproduced, they expanded, and the thylacines either starved or just couldn't compete.
So, bit by bit, the thylacine was driven out of existence across the mainland. The only proof we even have of those ancient populations are these. These mummified specimens found deep inside caves.
Yeah, like those on the Nullarbor Plains. The ultimate result was a forced retreat. Dingoes never successfully crossed over to Tasmania, so that island became the thylacine's final sanctuary. They survived that first wave of competition, but that safety, it proved to be temporary.
Which brings us to the second, fatal wave of decline. This one started in the early 1800s with the arrival of European settlers. And this time, the decline was rapid, it was brutal, and it was irreversible.
When Europeans arrived, the thylacine faced a perfect storm of four compounding factors. We have to understand this wasn't just one thing. It was a coordinated, systemic dismantling of their entire survival structure.
Okay, what was the first factor?
The first was competition and prey loss. Settlers started hunting the same small and medium marsupials the thylacine relied on. Even more critically, the Tasmanian emu, a documented prey item, was hunted to complete extinction by Europeans.
So a major food source just vanished.
Gone. The second was persecution and propaganda. Settlers arrived with sheep, and the thylacine, naturally drawn to easy meals like poultry, quickly learned to target these new domestic animals. This led to, well, hysteria.
And it wasn't just hysteria, it was government policy, wasn't it?
It was systematic elimination. Starting around 1888, the government put official bounties in place. You got paid for every thylacine head you brought in. This turned it into a hated pest, framed as this vicious sheep killer, a reputation that, the sources suggest was vastly inflated compared to the actual damage it caused.
But the bounty created a huge financial incentive.
A massive incentive to hunt the animal year-round, whether it was necessary or not.
And the third factor?
Habitat fragmentation. The spread of farms, towns, and roads just fractured the thylacine's territory. They needed large, connected hunting grounds to survive, and as their habitat was broken up, their ability to find food and reproduce just collapsed.
And what was the final nail in the coffin?
The fourth factor, which really accelerated the decline of the already struggling populations, was disease. The last documented populations were known to suffer from a form of canine distemper.
So they were catching diseases from dogs.
It suggests they were contracting a viral infection from introduced species dogs, other domestic animals, that they had absolutely no natural immunity against.
So you've got a highly specialized animal, already isolated on an island, facing loss of habitat, loss of its main food, financially incentivized hunting, and a deadly virus from invaders. It's no wonder the population just plummeted.
The cumulative pressure was just overwhelming. By 1930, the species was, for all intents and purposes, extinct in the wild.
And this is where the story gets just deeply historically sad. We know the timeline of the final few animals. The last confirmed wild thylacine was killed by a farmer in 1930. The few that were left were in zoos, and the writing was on the wall.
Breeding them in captivity proved incredibly difficult. Zoos all over the world tried, and they all failed to establish sustainable captive populations. The remaining individuals just slowly died out, one by one.
And the story of the very last known thylacine is heartbreaking, because it was completely preventable. His name was Benjamin, and he died in 1936 at the Hobart Zoo.
It was just tragic neglect.
Simple neglect. He was accidentally locked out of his sheltered sleeping quarters during a particularly bad cold snap in September. He died overnight from exposure.
And what really stands out to me is the bitter irony of the timing. The sources note that conservation efforts, the official recognition of the animal's protective status, were finally being implemented in the 1930s.
That is too late.
Way too late. Benjamin died just months after the species was granted full legal protection.
The species was officially declared extinct in the 1980s, but that has never stopped the chase. So let's shift to the present day and this lingering mystery. Was it truly gone? Because since 1936, the sightings have never stopped.
The sheer volume of unconfirmed reports is staggering, especially in remote parts of Tasmania, but also, bizarrely, in places like Western Australia and southern Victoria on the mainland. It has absolutely become a cryptozoology adventure.
Complete with bounties, right?
Complete with major bounties offered for definitive proof of life.
And while that proof remains elusive, the search is intense. People are using remote trap cameras all across suspected thylacine territory. What has all this modern searching actually yielded?
Well, the scientific community has yet to find a single confirmed photograph or video of a living animal. But there are these little sparks of hope that fuel the believers. Researchers have recently found scat and tracks that, based on preliminary analysis, might belong to a thylacine.
Might?
Might. The process of definitive genetic confirmation is still ongoing.
But if we assume for a moment that the animal really is gone, the ultimate scientific path forward is in de-extinction, and the genetic roadmap for that is essentially complete.
Yes, researchers have successfully sequenced the complete thylacine genome from DNA they extracted from museum specimens. The code of life is there. This makes the thylacine one of the prime candidates for de-extinction, right alongside the woolly mammoth.
So what does that cloning process actually involve, and why is it still described as a long shot?
Well, it's technically daunting. I mean, sequencing the DNA is one thing. Bringing an animal back to life requires taking that DNA, inserting it into the egg of a living relative, maybe a Tasmanian devil or a dasyurid, and then managing a successful gestation and birth.
That sounds incredibly complex.
The technological challenges are massive, and that's even before you get to the ethical question.
Right, it's not just flicking a switch. If they did succeed, they'd face huge hurdles. How do you fund the habitat restoration? How do you teach an animal how to hunt when it has no ancestors to learn from? And where do you safely release an animal that went extinct precisely because of human pressures that still exist?
It's a profound scientific and ecological undertaking. But if it were successful, the sources suggest it could revolutionize conservation. It might pave the way for bringing back other recently lost species, like the dodo.
So after this incredible deep dive, what does the thylacine story really tell us about the relationship between nature, evolution, and us?
I think it tells us that the thylacine story is this powerful synthesis of resilience and ultimately vulnerability. They were resilient enough to survive the arrival of dingoes, a natural evolutionary competition, by retreating to Tasmania.
But they couldn't survive us.
They couldn't withstand the combined rapid pressures from Europeans. The systematic persecution, the habitat loss, the loss of prey, the introduced disease. It was just a total failure of conservation timing and human management.
And so today, all we have left are those museum and lab specimens, the fragmented DNA, a silent warning to us. It feels like a call to appreciate the unique creatures we still have and to protect their ecosystems from going the same way. So here's the final thought we want to leave you with, connecting the past to this potential future. If we were to successfully overcome all the genetic and technological challenges and actually clone the thylacine, given that the historical factors that caused its demise, like habitat fragmentation and disease, are still very much present in Tasmania today, what profound long-term responsibility would we have to ensure its survival this time? And is the world ready for the marsupial wolf to hunt again?